Okay, factoring by substitution. This is a very useful tool. Just in general, we'll see it again when we do things such as this, where this is challenging to solve without substitution. But leaving this aside for now, but just letting you know that this is useful in many situations. What we recognize is that we have a something squared, and that same something to the first power. This is basically in the form of a quadratic, and we can simplify it. So I might take 5a plus 1, and just for convenience, I'll call it x. And of course I'll have to go back later and change it back, but this works for now. So replacing all of my 5a plus 1s with x, I have x squared minus 2x minus 3. You can go through factoring by grouping. You can also always, if you see it where just by trial and error or by eye you know what numbers can go here, or you can get there pretty quickly, you don't have to go through the whole grouping process. You can always go other routes and use the skills that you already have. Alright, so you might spot right away, oh, 3 and 1 will get me to 2. Okay? But you're not done, right? Because remember, x is actually my placeholder for this, so I need to go back and replace that. Right, x is 5a plus 1, and then there's the minus 3, 5a plus 1, and then simplify. Minus 2 here, 5a plus 2 here. Alright, which actually, interestingly, we have a difference of squares, but we'll leave it factored like that. Okay, another special situation, rational exponents. Actually, maybe I'll do a separate recording with that one, just because it's a fairly new and uncommon. But for this video, let me mention, because we're talking about factoring by grouping earlier, there are times where factoring by grouping lends itself to dealing with situations like this. Okay, this is not two x terms that I split up. This is actually a cubic polynomial. But at times, if you see a pattern, so I see a coefficient of 1 here and 4 here, you can potentially factor by grouping. So here I'll take out, again, the greatest common factor, and take out the greatest common factor. And it works out that these two things are the same, and so I can factor that out. And I'm done, because this does not factor any further. For example, this is not a difference of squares, and so that stays right there.